Let's go to the next speaker session number 2, the impacts of climate change on the ocean health. We have a very good expert about this one, Jean-Pierre GATTUSO. Is that that's your mic? Do I pronounce it right? GATTUSO?
Yes.
Yeah, you say yes with GATTUSO.
Yes.
GATTUSO, GATTUSO.
Never mind.
Never mind. I tried to do it right. What's the right name to pronounce?
GATTUSO.
GATTUSO. Okay. He works as a research director at the French National Center for Scientific Research, that's called CNRS, at the Sorbonne University. And he also works on IDDRI, and that's the Institute for Sustainable Development and International Relations. So you're the guy who's very well in being nice in politics, in relationships. No, really. Well, tell us everything you know. We should know in just the time you've got. Ladies and gentlemen, Jean-Pierre.
Okay, thank you very much for the introduction. So I was asked to talk about ocean health. And the first slide, I want to say that ocean health is a very fuzzy concept. There is no indicator for ocean health because ocean health is, depends on numerous variables. Biological integrity, that is the richness, the biodiversity, the food webs, the invasive species is also a measure of ocean health, the chemical balance, the oxygen content, the acidity of the water, the physical functioning, and we have heard from Sabrina a lot about it, the resilience to pressures, and that is the recovery following extremes, for example, a marine heat wave. Okay, there are bits of the slides missing. But I will focus mostly on the climate variables and how they affect the ocean and the ocean creatures. Here what you see is some kind of the sources. On the left-hand side, the sources of CO2 to the atmosphere, mostly the burning of fossil fuels, and at the bottom, the CO2 emissions coming from changes in land use. So on the right, these are at the bottom the sinks, vegetation and the ocean are the two sinks, that is areas which store some of this anthropogenic CO2. You see that the ocean, in fact, absorbs 25–26% of all CO2 emissions. So it's a chance, because if we didn't have an ocean, we would have much more CO2 in the atmosphere and negative impacts that will be, in fact, much larger than what is projected today. The rest, about 50% of the CO2 stays in the atmosphere and contribute to climate change. So if you want to illustrate where the role of the ocean in those variables, I mean, as Sabrina said, the ocean stores most of the extra heat resulting from the release of CO2 in the atmosphere, more than 90%, which warms, of course, the water. For CO2, as I just said, about 25% goes into the ocean, which leads to ocean acidification, that is an increase in ocean acidity. And the 100%, of course, of the melting of ice sheets and glaciers, the water goes into the ocean, contributing to sea level rise, together with warming, which also contributes to sea level rise. I forgot to say that warming also induces a loss of oxygen by the ocean. So when you look at the colors on this slide, the blue is predominant. It really shows that most of the big role of the ocean in the climate system. It is something that is inescapable, and that's a good reason to have conferences like UNOC or the Congress that we organized earlier this week. So this is a figure that the next speaker knows well. Comes from an IPCC report published in 2019, which tries to summarize everything that I have said so far. And we will go through a few of the effects just now. Same slide. At the bottom are impacts on the ocean. At the top, the cryosphere, because this report was combining the ocean and the cryosphere. The marine heat waves were mentioned by Sabrina. They doubled in frequency in the past decades, and when they are severe, they cause coral bleaching, the loss of algae, which are essential for the life of corals. And when coral bleach, if the heat stress is too long, they will die. They are mass mortalities. That's a big problem. Kelp forests are also very sensitive to heat waves. And the prospect is not very good for the future. I mean, there is a modeling shows that the heat waves will increase in frequency and also in a surface area, and this is something that is very much, again, massive consequences. Even here in the Mediterranean, in the Bay of Villefranche, where I work, we have measured last August 29.9 degrees at the surface, which is unheard of. It's 2 to 2.5 degrees above the historical mean. Oxygen content, of course, ocean warming reduces mixing between the surface ocean and the deep, since the only source of oxygen, not the only source, but the major source of oxygen is from the atmosphere. If you cut the mixing, then there is a loss of oxygen at the bottom. The oxygen cannot be replenished from the surface. Ocean acidity, that's, as I said, the result of the uptake of CO2, which changes the chemistry of seawater. So the ocean, since the Industrial Revolution, has absorbed 20 to 30% since historical times, and this will continue, and acidity has increased 30% since 1850, with severe consequences on calcifying species such as corals, mollusks, mussels, oysters, species that have a calcareous calcium carbonate skeleton or shell. So one needs to make the case for the ocean. You have seen the critical role of the ocean in the climate system. We also know that there are already today massive consequences on marine organisms and ecosystems, with severe consequences also, for example, on fisheries. And there are 20 species that have been extinct. There are 330 species which have a status given by the IUCN, the International Union for the Conservation of Nature, being of conservation concern. There is a big decline in exploited marine megafauna. 1/3 of fisheries are overexploited, 2/3 of fisheries below target, and a big loss of biomass in exploited fish stocks. And here again, I have parts of my slide missing, but that's okay. So now, there are many negative impacts of climate change on the ocean and ocean creatures. What do we do about it? So if you look at, if you consider the atmosphere as a swimming pool, and the CO2 added to the atmosphere, we use this picture of having a hose that you open and fills that CO2 filling the swimming pool. So the swimming pool is filling and is able to overflow, could overflow. So what can we do? Either there is a drain at the bottom of the swimming pool. These are the carbon sinks that I have described. So what you can do is turn off the hose, reduce emissions. You don't want the swimming pool to overflow. You can make the drain bigger, and there are studies at the moment to have marine carbon dioxide removal approaches are anticipated. Or you learn to swim, because you need to adapt to those new conditions. So here you have mitigation, CDR, carbon dioxide removal, and on top, adaptation. There are many ocean-based solutions. I won't go into the details, but they are grouped into 4 categories. One, of course, is addressing the causes of climate change. That is reducing CO2 concentration in the atmosphere, either by reducing emissions themselves or by using renewable energy, for example, to compensate or use MCDR, marine carbon dioxide removal, supporting ecological and biological adaptation. There is a very controversial one that is solar radiation management, and finally enhancing societal adaptation, for example, constructing dikes like in the Netherlands. I skip that. So the key messages. The ocean is a key element of the life support system. Provides food security to many areas in the, so there are many measures to cover. Several of them are unproven or risky, and we don't advocate for the implementation of those solutions, but one needs to implement the decisive and low regret. Low regret, for example, nature-based solutions, restoring coastal ecosystem, plants that are storing CO2. Then I just want to go quickly through the outcome of the One Ocean Science Congress that took place and ended yesterday. We have several products, and one of them is a manifesto that you are welcome to sign. You will find the link on the internet, and those recommendations will be provided tomorrow late afternoon to the heads of states and government. So without going into details, we advocate for acting now when science is solid, and there are many areas where science is solid enough to act. Inaction is indefensible. I'm not going through that, but for example, those items here are fairly obvious, and we know these are very good solutions. We need to advance knowledge when there are uncertainties, and there are several areas where research should be more promoted and better funded. And for example, we advocate the pause of deep sea mining because there's so much uncertainty in the deep ocean that doing deep sea mining now will be absolutely detrimental to the ocean. Also, MCDR needs to be better investigated before it is implemented in a large scale. And more generally, to support science-based regenerative blue economy. And the last part is to turn knowledge into action and action into justice. The knowledge must serve the people and the planet. And there is a very large inequity on this planet. And the dikes in the Netherlands have been mentioned. But in fact, Netherlands and the UK, for example, concerning the dam on the Thames, those are very rich countries. So they can afford it. How about the South Pacific islands and small island states? And these do not have the possibility to have large-scale infrastructure being built. So there is a very big inequality, especially when you consider that the Global South has nothing to do with the climate problem. I mean, their emissions are ridiculously small compared to ours. So it's important to upload the rights and the knowledge system of indigenous people and local communities, and that is what we will argue, suggest to the heads of states and governments tomorrow. Thank you very much.
Thank you. Any questions to Mr. Jean-Pierre? Questions? Oh, wait. Mr. Atier.
Yes, Jean-Pierre, thank you very much for your presentation. I come to this conclusion. Yesterday we talked about ocean observations, and I think somebody explained that it's mainly funded by research funding, except satellites possibly. And my question is whether there is any form of recommendation for operational funding of a core of observations which would safeguard and the system and leave other resources free for research, investment, and addition to this core element. Because we have been suffering from this for years. Satellites are now funded operationally since 2014 in Europe, but nothing happened for the observation of the deep ocean. It's still research, and we know in the current situation that the core is even endangered, like Argo and others. Thank you.
Yes, as far as I know, there is no such process in place, but you are perfectly right, and we argue for improved observations and modeling. And with regard to observations, we just published a paper earlier this week on the disaster that is unfolding in the US. With respect to US federal agencies such as NOAA, NASA, EPA, the Environmental Protection Agency, with NSF, the National Science Foundation, which funds, by the way, a lot of Argo floats, and now funding is frozen at NSF, which is a big problem because the Argo program, those floats that go up and down in the water column, this Argo program, the US is maintaining 51% of the floats. So if the US goes backwards, that is a major issue for ocean observations.
Jean-Pierre, thank you for your presentation. My name is Paul Gross from Detroit. Those of us that communicate climate change, we talk a lot about things like sea level rise and marine heat waves and things like that. One thing that I don't hear talked about enough, which you addressed, is the oxygen content. And I'm curious, are there regional differences in that? Are we approaching tipping point? Can you maybe quantify a little bit where we're at with the oxygen content, what the implications are, and are we near a point where, like we talk about the AMOC, and are we going to see a collapse? Well, are we going to see a point where, is there a point where that ocean oxygen content becomes more severe, and then we see, ramifications?
Yes, thank you for the question. The IPCC has estimated that the ocean has lost about 4% of its oxygen content globally. But there is a lot of regional variation. There are what is called, in popular terms, dead zones. There is one in the Gulf of Mexico, and please allow me not to use the term Gulf of America. There are others in the south.
No politics. No politics.
There is also areas which are very poor in oxygen, that is in the northern Indian Ocean, and those regions are expanding spatially and also in volume. And the consequences, since you asked, is of course a big problem for animals, because animals need oxygen to respire, and there is a serious issue there with the fisheries in these areas of dead zones.
Any more question? We've got time for one more question, if needed, if requested. No, well, thank you so much
Thank you
for your contribution about the health of the ocean.